Okay, so what I want you to write on your notes in that blank spot is this equation right here. S equals negative 16t squared plus V naught. That's what that little zero means down there. V naught t plus S naught. What?
Which no? Well, you got to write the zero.
Instead of saying V sub 0, it's just saying, it's pronounced V naught. Now, how many different variables do we have in that equation?
2, 3.
Closer.
4.
Technically 4, okay? You have S, T, V naught, and S naught. You always need to know what all of these variables stand for, okay? So take a moment, read it to yourself. Easton, can you tell me what S stands for? Feet. That's the label for it, but what is it? Height. Okay. So please write this down. S equals height in feet.
Always in feet?
For this equation, yes. For this formula, yes. What does the T stand for?
Time, I'm guessing.
Time in what? Seconds. Now, this V naught, so the V with the little zero there, what does that stand for?
Velocity.
The initial velocity. Okay? The initial velocity. Okay, now a label for velocity would be feet per second. It has the longest label. And then our last variable, S naught, what does that stand for? The initial height, where you're starting out from. Now, what is our label on our initial height? Feet still. And the reason why S naught is different from S is because where you start from is going to be different if you're starting on the ground versus if I stand up on the stool and throw something. Okay? So that's why we have that S naught there. Okay. Do you have all 4 variables written down? With all of their labels? Okay, because I'm going to push this button and they're all going to go away. Let's take a look at this example. The CN Tower in Toronto, Ontario is one of the tallest self-supporting structures in the world, standing 1,821 feet tall. Suppose an object was dropped from the top of the tower. Find the equation S equals negative 16t squared plus V naught t plus S naught.
So your first S is going to be 1821.
What do you mean when you say first S?
The height.
Do you mean this one or the one at the end?
The first.
No.
Why?
Well, because that's talking about how high the object is after a certain amount of time.
So the first S just stays S. But
Yes.
S naught would be 1,000.
Good. Your initial height, where you're starting from, that's going to be your S naught. So it's going to go back here.
Okay.
Now, when you drop something or when you throw something, Carson, after 3 seconds, this will be a certain number. But after 6 seconds, it's going to be a different number.
Okay.
So we're coming up with the equation, and we want that over here.
So we're never going to have to change the first S unless it tells us it.
Correct. Okay. All right, so that's going to go in there. Have they given us a number for V naught?
No.
No, but if you are standing still and let something drop,
It's 0.
it's 0, okay? At the initial velocity for this one, it's just nothing's happening yet, so our V naught is 0. So if we have V naught is 0 and S naught is 1,821, plugging those into our equation, do we have anything to plug in for S?
No.
No, it's supposed to be there. Negative 16, do we have anything to plug in for T?
No.
So we leave that as T squared. Now, if I was to write down plus 0T, would that do anything?
Mm-hmm.
No, so we'll just leave that one blank. And then at the end, plus 1,821.
So S equals negative 16t squared plus V
any height of a projected object. That's like your standard go-to formula that you start plugging stuff into. All right, now, at what time will the object hit the ground? If you're hitting the ground, what's your height there?
0.
0, okay? So when you want to hit the ground, that's saying let s equal 0, solve for t. So if we have 0 equals negative 16t squared plus 1,821, and we need to solve for t. Would this one be particularly difficult to do by hand? No, not really. What would you do first? Move what over? You could, or you could move your squared term over just so it becomes positive to begin with. So we'd have 16t squared equals 1,821. Carly, what would you do then?
I divide by 16.
Agreed.
Oh,
Divide
yeah,
both
that's
sides
a
by
beautiful
16.
number.
Yeah. So we have t squared equals
113.8.
113.8.
Square root.
Okay.
Where is the square root of it?
All right, that actually isn't too bad of a decimal, so we're going to include all of them on there. And then to do a square root, press second x squared. Go ahead and do 8125, please.
Do you want it as a decimal?
Sure. Well, how else would you take
It
it?
didn't really
But
change.
you know if you want to just round it.
Whenever you add the other number.
Oh, I'm catching what you're pitching. Okay. That's a good point because it is time. We'll go ahead and, yeah, we'll round it. So t is approximately what? 11 what?
Seconds.
Seconds. Normally when you're doing a square root, you also have to include plus or minus. Why don't we need to worry about that
Can't
here?
have negative time.
Good. You can't have negative time. So
Not time travelers.
after approximately 11 seconds, it will hit the ground.
So when are we ever gonna make time travel?
Not.
I know.
Okay.
When can we ever time travel?
Chrissy, are you okay with this?
Everything will be screwed up
Okay.
if we can.
Ashley, are you all right? Lacey, you okay?
We can go back and hunt dinosaurs or something.
Cody, you got this down?
Yeah.
Okay.
Maybe that's how that went.
Could be a little pterodactyl.
Yeah, maybe that's one of them.
All right. Let's take a look at this one. From 1985 to 1992, the number of hours spent annually per person watching TV in the U.S. can be modeled by this function right here. This h of t equals 3.8 t squared minus 29t plus 167, where h represents hours and t equals 5 represents 1985. According to this model, in which year will the number of hours spent per person reach or surpass 400?
Please release junior high track at this time.
Let's talk about this t for a moment. They're saying that t equals 5 represents the year 1985. So what would t equals 6 represent? No? If t equals 5 is 1985, it represent 1986. Good. What would t equals 7 represent? 1987. Okay. Dylan, what would t equals 8 represent?
When you add like, wait, what do you add now? Hang on.
We're going up by 1.
Are you going up by 1?
Well,
88.
okay, look, 5 is 1985.
Yeah.
6 is 1986.
Okay.
7 is 1987.
88 then.
It's really handy when you pay attention.
Yeah, pretty much.
All right. So does everybody understand what the t values are
Yes.
representing? Okay, they will represent some year. If it's 5, it's 85. 6, 86, so on and so on. Okay, now, they gave us this 400. In which year will the number of hours spent per person reach or surpass 400? So where do we put that 400 in our equation?
T.
T equals 400.
No.
No.
Why h?
Because you're multiplying that by something.
No.
No?
Because it's the hours spent.
This is asking in which year will something happen. Which of our variables up here represents the years?
T.
T. So they're asking us to solve for t. So if we're going to solve for t, Where do we have to plug that number in for? H. Also, labels. It's asking for the number of hours. Will the number of hours spent per person reach or surpass 400? So that's like saying, when is it going to be more than 400 hours? Well, an hours number, do we plug that in for H or in for T? H, okay? You have to know where you're plugging your variable in. Now, this equation, if you're plugging in 400 here, so we're looking at 400 equals 3.8 t squared minus 29t plus 167. Is that one that you want to solve by hand, or would it be easier to use our graphing calculator? Probably the graphing calculator. Now, on the right-hand side, what shape is that going to be?
One parabola.
On the right-hand side, that's going to be a parabola. A parabola that opens which way? Up. So we expect that to look like a parabola. On the left-hand side, that 400, what do we expect that to look like?
Linear line.
Not linear.
Diagonal, whatever it's called.
No. Horizontal. It's just a number by itself, so it's a horizontal line. You need to be able to see that horizontal line, so you're going to need to change your window. Okay, so
Linear.
calculator's ready.
Isn't linear and horizontal the same thing? They're both a straight line. Like I know
No.
horizontal is across the plane. But linear can be
Horizontal is actually just one way, but linear can be diagonally up, diagonally down, and then the steepness of it can change. Whereas a horizontal, it stays constant, which is why we call it a constant function the whole time. Excuse me.
Wait, so like just never mind. I have one variable.
You gotta change your window. You should make your water deck 450. Anything above 400.
I thought I could. Yes. Once you find your graph, you're looking for the intersection. Was everybody able to get the picture? Ashley, graph it, come on. And you were able to see it, and you got two answers? Do we want both? Okay.
Use some text.
Lacey, were you able to find the picture?
Okay. I did not get that pictures. I didn't send that.
This is a fun game.
Won't you take me?
Okay,
Like mine cooking.
I'll come look at it in just a moment. I want to rotate.
Which one did you put
Yeah.
Yes, I got mine -10, 30, -10, 500.
That's a cubic. We need quadratic. I swear.
Gotcha.
second thread?
One of those today's
Partition.
Are you getting something like 12.526?
Yep.
Yes.
Or are you able to get 12.526? Fantastic. Dylan, did you get 12.526?
Got it right here on the calculator.
Fantastic. Okay. So T equals 12.526.
What do you just want?
Is that what we write down for our final answer?
Nope.
No. Okay. If T is 12, what year is that?
92.
How do you know?
Just keep going again.
You just keep going up by one, right? Okay. So we knew that when it was 5, it was 85, which means if it was 10, it'd be 90. So if it's 12, it's 92. Is everybody okay with how we're getting the year there? Okay, because I can do it one by one if you want. I don't mind. Okay. Now, let's talk about the fact that this is a decimal here. 0.526, that means that it's the year 1992.
Halfway through that year.
Like June. Yeah, halfway through that year, okay? So, according to this model in which year? Okay, so in 1992, the number of hours will surpass 400.
To be there.
Gracie, are you okay? Which part? Like,
Well, like, the 12 point, like, I understand how we got that, but how does that apply to our equation? Problem.
well, when 400 is your h value, so when 400 equals 3.82 t squared minus 29t plus 167, that is a true equation when t equals 12.526.
How'd you figure out that was like in the middle of June, or like that was like June?
It's the 0.5
The
like
0.5, as a decimal, that means halfway. Okay, so halfway through the year would be June. And I really just care, Dylan, about the year. Just tell me that it's 1990.
Yeah, that was the dip. I knew how to get it, but I was just.
You just wanted a little extra knowledge.
Yeah.
I like it. Charlie, are you okay?
Yeah. You.
Okay, last one.
That's what it was.
Okay, so Dylan finds a piece of property roughly in the shape of a right triangle.
Wow.
Okay? He finds that the longer leg is 20 meters longer than twice the length of the shorter leg.
That's a lot.
That's not all.
The hypotenuse is 10 meters longer than the length of the longer leg. Find the lengths of the sides of the triangular lot. What should we do first?
Draw a triangle.
Good. Specifically, what type of
Draw a
triangle?
right triangle.
Good. Are they all three sides going to be the same?
No.
Okay. Oh, not my best
I'm gonna
triangle,
try
but we'll work
triangle.
with it. What, darling?
Where? Oh, there it is.
Find it?
Roughly
Nice.
in the shape of
So, Dylan finds that the longer leg is 20 meters longer than twice the length of the shorter leg. Where are the legs here?
Okay, so you got your
one.
20x there on
Left.
that one right there where you're pointing at.
What should we write here?
20x. Because
Um,
20
X
times
plus
it-
20.
it's
X plus 20.
x plus 20.
Then the bottom one.
Finds that the longer leg is
It's all right there.
20 longer than twice the length of the shorter leg. I'm going to say 20 plus x is not good enough.
20 plus x, or 2x.
Good. Right here is where it says 20 longer than twice, means you have to take 20 plus 2x. Which means x goes where?
Bottom.
On the bottom.
The other one is 10 plus 20 plus 2x.
Very good. For the Easton, are you okay that this is 20 plus 2x?
I just did 2x plus 30.
And that's fine, you can do that as well. All right. Gracie, are you okay that here's x?
Yeah.
And then since the hypotenuse is 10 longer than the length of the longer leg, if you're going 10 more than this leg, you can write that as 10 plus the 20 plus 2x, or you can combine them and say, okay, so that's 30 plus 2x. Either one's fine. Are you okay with the picture?
Okay, so yeah.
Now, if you have a right triangle, we have to come up with an equation, like it wasn't given to us this time.
H.
Ashley, what could we use?
20 plus 2x plus squared plus 30 plus 2x squared.
Good, you may remember what that's called.
Pythagorean theorem.
Very good. All right, so we're looking at x squared plus quantity 20 plus 2x squared equals quantity 30 plus 2x squared. All right, again, you can do this by hand or you can do it on the graphing calculator. That is a lot of parabolas running around right now, so I might clean it up just a little bit before graphing it. All right, now, Dylan, if you square a binomial, what does that give you?
Trying to.
Go for it.
Wait, which one?
How about this one?
Get like 40,
How about 400?
400. Why
Okay.
did I say 40?
I don't know.
You silly.
Because I was thinking 20 times 2. There you go. And 4x. Right. That's 4. 8x. How?
Because you got 40x plus 40x.
Are we doing that one right there?
This
Yeah.
one right here, yeah.
2 times 20 is 40.
I
You gotta have 2 of those. 40
Yeah,
plus
but-
40 is 80.
Wait a minute. What are you? Oh, okay. I see what you're saying. Yeah. 40x.
80!
80x. Sorry. All right. I'll get it here. And then what now?
4x squared.
There you go. Right there.
Gracie, could you do that one?
Oh gosh.
Don't worry, it won't be as
Let
bad
me
as
just
Dylan.
write it out.
Well, I didn't write it out. I read it out, but.
I gotta write it out. Okay, so 36, 900 plus 120. And then 4x.
Right now, what do you notice on both sides of the equations?
They are these parabola thingy. You can put them together.
Let's condense that just a little bit more. Does everybody see that there's a 4x squared on the left and on the right?
Yeah.
So what happens?
They're gonna cancel each other out.
Okay, so that's gone now. Are there any other x squareds left?
No.
Yes, there is.
Where?
On the
yeah.
left.
Right in the front.
Okay.
Where?
So we've got an x squared plus 80x plus 400 equals 120x plus 900. Is this still a quadratic equation? Yes. Okay, what do we like quadratic set equal to? Zero. Okay, so I'm going to pull the right side on over. So if we subtract 120, I think you get negative 40.
X squared minus 40x minus 500 equals 0.
All right, now at this point, you can use your graphing calculator, but Easton, does that factor?
Possibly.
Can you multiply to be 500 and add to be 40? Technically negative 40. I was thinking 50 and 10 might work.
Oh.
Multiply to be negative 500, add to be negative 40. I believe if you go with negative 50 and positive 10. Okay, so this gives us x plus 10 times x minus 50 equals 0. So that leaves us with x equals negative 10 or x equals 50. Cody, do we want both of those answers?
No, just, yeah.
No, you just need a positive.
No, you don't. I guess it's later than the x, it equals negative, so just fine.
Right, this one's a positive one. Okay, all right, now, it says to find the lengths of the sides of the triangular lot. Right now we've got one of them. Is one of them good enough for our triangular
No,
lot?
we need to have all three of them.
You need to have all three. So, Miss Lacey, over here, if x is 50, what would 20 plus 2x be? Shh. 120. All right, and then Carly, the hypotenuse? Yeah, 130. Okay. So then as a complete sentence, the lengths of the sides are 50 what?
Meters.
50 meters, 120 meters, and 130 meters. Labels are important. 120, 130, and 50. And remember that you do have to write your answer in a complete sentence.
Of course, if they'll put your notes the way I did them.
Has everybody got this one down?
Sure. Houston.
Gee, he doesn't write notes.
Here we go. Time for the assignment.